So we're continuing this couch settee thing. So we've already modeled up the high res from a low res cage, and the next step is to convert this or create properties. Let's just reduce that, armrest. The next step is to generate a low resolution version of the high resolution version that's going to give us a platform essentially to bake our normal maps to, which is why we did the high res. So this is the cage. Essentially this is the block out, the object that is used to generate our high res shape with subdivisions. Well, this is actually without at the moment, but this is what we apply our subdivision surface modifier to. And in this case we've got three components. We've got the back and partial arm, an armrest, and the seat, and they're separate because it's easier to try and, well, make this kind of corner with this object being one object rather than trying to match up two objects together at a very awkward alignment. So rather than using two objects, we just combine everything into one object and then create the corner that we need, which is then matched up more easily to a, let's just hide the seat for a second. This makes it easier to match two objects together because we've just got a flat line, a flat surface, or flat edge. So what we can do then to make our low res mesh is use this. So rather than doing what we might normally do, which is maybe use retopology or remake or rebuild a completely separate low resolution version of our high res. So let's just enable the... What we can do instead is use our high res, well, use it as the basis for creating our low res. So what we can do, take a look at the shape that we've got. So when we do the high res, so that is the armrest. Let's go to 3. So that smooths out the silhouette so that we don't get as much faceting. But what we can do, so that would be the high res, is reduce the subdivision levels and assess which is going to give us the best shape. So because we've got a lot of curves on this, we want to pay attention to this silhouette. We don't want this to be too faceted, because even with normal maps in place, this might present us with, it's not an issue so much as this curvature being faceted like this will be visible in game. So what we might need to do here is keep the subdivision levels relatively high, because what we can then do, and this is the trick so to speak, is let's just do a duplicate of this object, duplicate of, oops, not duplicate, linked. We just want duplicate objects, escape to reset, Let's just move that to one side so that we can see it. Disable the mirror modifier. Because what we can do exact duplicate. What we can then do in our properties and under our subdivision surface modifier is apply it. So click on the more options button and then click on apply, and this will apply this level of subdivision to our very basic mesh. So this was our basic mesh, our block out essentially, that we've got the modifier assigned to. So we want 2 levels to keep this roundness so that we don't get hard faceting. Otherwise, let's just reduce that. Otherwise we'll get that, or we want to avoid that as best as possible, because that's going to be visible in game, because this is quite an acute curve. So we want to keep the high res, which reduces that faceting, so it makes it more difficult to see the flat edges. Then with that we can apply the modifier. If we go back in here, we can see that that's created a pretty dense mesh. But we have our silhouette. This is the important bit, because what we can do now that we have this, so that's our original and that's our duplicate with the subdivision surface modifier assigned to it. So what we can do now is simply go into edit mode and optimize this structure. So generally speaking, in this particular instance, we want to keep this curvature, so we don't want to necessarily edit these edge alignments or edge loops. We want to remove these edge loops that don't really help us define too much shape in this orientation or this direction. So we have much greater latitude to remove these edge loops. So that was Alt click, than we do when we need to remove these edge loops. But saying that, we're going to be able to keep these, but we might be able to remove these, because these don't describe too much shape from about this point actually. So from this point downwards, we might be able to remove quite a few of these, which will reduce the density or complexity of the mesh. So let's just, before we do that, enable statistics. So that's viewport overlays, statistics, and this will show us the complexity of this particular mesh. So right now it is 2,880 faces or 5,700 triangles. We want to reduce that down as much as possible. So let's start with the easy stuff first. So Alt click, then mesh, delete, dissolve edges. So what this will do is it will remove this edge loop without altering the structure of the mesh. So X, dissolve edges, and we can remove these, and we can see whilst we do that, let's go into view, viewpoint top. We can see how this is not necessarily going to be altering the silhouette. So that's the outline essentially. In this orientation. So X, dissolve, X, dissolve. What you might find is to do every other edge loop, and then if you can, go back and remove other ones. So we're doing a, so we started with this one, this one, this one, this one, and this one, and that's defined the shape as we have it now, but we might be able to go back and dissolve maybe this one and this one. So don't delete all of them, just go in odds and evens. And again, when we get to these tighter corners or curves, we want to try and keep as much of this shape. So and then of course on the inside we can pretty much get rid of nearly all of these, because we only really need the outside and that very inner edge loop. Let's just select these so that we can rotate properly on this. So that's the numpad delete, so that we can get to inspect this curve. So we might just need this one and this one, because this curve can be described by a straight line and possibly this line as well. So we're looking at our shapes, keeping in mind that we're going to be using normal maps for this. So the normal map would be describing visually this curve, but the mesh itself doesn't need to be like that. So this would be an inner edge of this section. This would be that section, and then we've got this section. So this edge might be our intermediary. So we can get rid of this one, this one, this one, this one, this one, this one, and these potentially. And whilst we do that, if we keep an eye on what's happening with the complexity of the mesh, it should reduce quite significantly. So X, so that's loop select again, X, dissolve, X, dissolve, X, dissolve. Let's go with that one, X, dissolve, dissolve, dissolve. Yeah, and dissolve that one. See how much that's reduced it by. So that means we can get rid of this one, this one, this one, and again go back to this one. Get rid of that one, that one. So we can see how optimizing is basically keeping the general profile of the high resolution structure of the mesh, but we are essentially reducing it down to its core, not core components, but the angles and planes, that we could, that still basically describe that curvature. So if we look at the original, let's just get rid of the, I'll turn that off for the moment, the mirroring. Bump that back up. we won't necessarily be able to see the internal structure of the mesh in this particular instance whilst the, oh, maybe we can actually, can we? Where's the optimal display? There we go. So we've just removed all of this, essentially describing this curve, and reduced that down to this, which is what, 3 or 4 angles. That's 1, 2, 3, 4, and that's what your optimizing needs to do. So let's hide this for the moment, or actually let's just hide the back seat because we don't need that to be visible right now. But we'll keep this on screen so that we have a comparison. Let's try that one. That one. Right, so now we're starting to facet a little bit. Let's just undo that, which we want to try and avoid. So there's a limit to how much we can take out to describe this silhouette. And there's a limit to how much we can take out to describe this silhouette. But there's a lot that we can take out. So let's start that one, that one, that one, that one, that one, that one, that one. And we can see that taking these out isn't altering this profile. So in terms of optimization, that's basically what we're trying to do, is remove structure in a way that doesn't necessarily alter the silhouette or profile of the mesh. Let's try this one. Yeah, we can get rid of that one, that one, that one, that one. Maybe not that one. Let's leave that one in place for now. The curvature, that one. We might be able to be more aggressive with these corners because they're relatively small in terms of how the object is going to be used in game. In other words, because the user doesn't get close to these, you can't really see the curvature, so it can be removed. So can we remove that one? Maybe. What about that one? That's probably the better one to remove. Right, so remove that. So this is where it might get a little tricky because of the structure of the mesh, but we can pretty much remove all of these inner faces because this is essentially a flat face. So it should only really have connections to the rest of the mesh on these outer vertices. So that removes all of this waste that's not needed, because it doesn't describe a shape. That's the key. It's you're removing things that do not describe the shape of the object as a low resolution mesh. So get rid of those. Right, so this is where it gets a little tricky because that edge flow now goes around the mesh. So what we can try doing here is paint select those. So that's the C key. Shift Alt. Paint select these out. So what we're doing is creating a continuous edge loop here. So we're going to remove these. So we have to shift click these individually. Let's try that. X, dissolve edges. That works, but it's given us some funky shapes here, so we'll have to keep an eye on that. And here, same again. Let's try deleting those on their own. And that's given us a rogue vertex, so let's try dissolving that on its own. So we're now going to essentially create an n-gon in certain places. But that's okay because we can fix that. Whoops, collapsed. X-ray. Paint those out. Delete or dissolve. Paint those out. Dissolve. Let's see if we can delete that. Dissolve. Is that going to collapse? No, that's okay. So we can keep this central one for the moment. Let's try deleting that. Yeah, it's going too faceted. Undo. So we need to tidy up this area. In fact, actually, let's just check this profile. Okay, let's get rid of this edge loop. That wasn't really describing any shape. We might be able to get away with removing this and relying on the normal map to describe this shape or this curvature as mentioned before, but we'll have to see how that goes. So this is where it gets interesting. So let's do an edge slide. Double tap G key. Double tap G key. So we're going to create a pole. That's where a set of vertices a line around a single point, which in this instance isn't bad. And we want to merge these, so mesh, cleanup, merge by distance. So that's reduced us by what? That's off screen at the moment, but that's taken a couple out, so let's make some adjustments to the mesh. Get that roughly centered. So we've gone from, what was it, 4,000, well, it's 360, but 5,700, 5,700 triangles. We've gone from that to 608. And if we look at our shapes on profile, or from the profile perspective, front, this is what we want. So 5,700 versus 600. 5,700, 600. And if we look at the profiles, or the silhouettes as they are called in professional circles, there isn't really that much noticeable difference between the two. And this is what we're trying to achieve with our optimization. We're trying to reduce the high res down to a low res that's going to capture the essence of the high resolution mesh without any of the overheads for our low res, because that is what we'll use the normal maps for. But might take a bit of trial and error to do something like this, but this is what you need to do for your game assets. Let's try removing that. That might be a bit too aggressive. Let's try removing that one. That's okay. So let's just quickly sort out these dodgy areas. So let's edge select that and see if we can edge rotate, edge rotate. There we go. Same with that one. Edge rotate. It sometimes gives us issues when we are trying to rotate an edge. So basically what we're doing here is changing the orientation or the alignment for these edges so that they create a fan. But sometimes doing this, especially when we've got an n-gon, that's a polygon with more than 4 edges, it can be a bit of an issue, so we have to be aware of that. So where's edge, rotate, edge, rotate. So what we might need to do here is rejig this a little bit, or vertex select, shift click, press the J key, create an edge. So that is connect vertex path. So vertex, connect vertex path. That's the menu option for it. J, 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 J. And where we can, we want to try and avoid making long, thin triangles. So if we can edit or move the mesh around to reduce that and create a semi-even distribution, we can do that. So that looks like that will be our final low-res mesh from our high-res that will now, obviously we've now got to replicate this reduction. Now got to replicate this reduction across the other objects. So where's the back? Which one's, oh, there it is, back. So let's hide that. So we've now got to do the same thing and carry this optimization across this, and this is going to be a tricky area to do that too. But that's what we'll need to do next, but do that off screen because it's just basically a repetition of the process that we've been looking at. So the next stream, the next live stream, will be looking at UV maps and textures. And then the one after that, we may then start baking normal maps, baking our textures. But today, all we did, I say all, back, let's hide that. So all we did today was basically reducing our high-res subdivision surfaced mesh down to a game-ready version. So we've gone from 5700 down to 500. That's a huge reduction. A huge reduction whilst maintaining the overall profile of our mesh. Well, the high-res version at least anyway. So that's what optimization is all about. Right, so we'll call it quits there for today, or for this video. And as mentioned, in the next one, we'll take a look at UV maps. I'll do the rest of the chat offline because, as I say, it's just a repetition of the same process. And then the next one will be UV maps and textures, or your materials. Right, so thanks for lurking, lurkers. We'll call it quits there, and we shall see you on the next live stream. Right, so bye for now. Yoink.